All right, so we're going to look at geometric sequences in series today. So geometric sequences have a common ratio, which we call R. And you can generate the terms of a geometric sequence by finding the geometric mean. So we define it as the missing terms between two other terms in a geometric sequence. So there's different ways you can find it. Sometimes a little guessing and checking. I mean, if they're doubling or tripling or halving, which is pretty common to get from one term to the next term, it's pretty easy to find the missing terms in a geometric sequence. There's a process you can go through for finding the geometric mean between two numbers. You just multiply the two and take the square root. So you might want to add that in. Multiply. If there's just one value in between, you're finding multiply and find square root. I'll show you what I mean by that. The geometric means it's different than an arithmetic mean because it's part of a different type of sequence. And there's a formula for generating the nth term of a geometric sequence. Geometric sequences are exponential, either growth or decay sequences. Functions. If we were to match them up to a function, they're exponential. These are going to be discrete values. But here's our formula. A sub n equals a sub 1, that's the first term, times r, which is the common ratio, to the n minus 1 power. And so if a sequence is geometric, there will be a common ratio r. So can you identify which ones up here are geometric? What's one up here that's geometric? First one, let's see, 6. Third one is? Okay. The second one looks like it is. First one, it's not arithmetic. How would you check to see if the first one is geometric? Like, what's the common ratio? First one. Okay. You'd have to check pairs. Yeah, 9 divided by 6 equals 1.5. And what's 13.5 divided by 9? 1.5. And then is 20.25 divided by 13.5. Okay, so this one's geometric. It has an r equal to 1.5. And then you said the third one. So what's the r on this one? -1. Yeah, it's an interesting one. What about the second one on there? 1/4. Okay, so if we take 3 over 12, that's equal to 1/4. And if we take 3 over 3/4, oops, other way around, 3/4 over 3. So 3/4 divided by 3. I kind of think of that as 3 over 1, which would equal 3/4 times 1/3. So this one, does it work for 3/16 over 3/4? It has to work for all the ones listed. There. Looks like it does. So this one's r equals 1/4. And then the last one here is just, it's still geometric, it's just in a different form. If we needed to, we could start writing down the terms. It's 2. And then the second term would be -3 times 2, or -6. The third term would be -3 times -6, which is 18, and so forth. So this one is r equals -3. So that's what it'll look like when it's recursive. But these are all geometric. So these are all geometric. And they're geometric if they have a common ratio. And then there's just the same types of problems that you'll be asked to do here. This is really, finding the geometric means is really equivalent to just finding the terms of the sequence. So if we have 5, comma something, comma something, comma something, 80, you might be able to just algebraically think of that. The formula that I told you, it works like this. If I want to find this guy right here, which works great if there's an odd number of means between them, this will work. You can just do 5 times 80 and then take the square root of that number to get that geometric mean between them. It's not halfway between them, but the geometric mean, that's the middle term between them. So that's 400. Square root of 400 is 20, so this is 20 right here. I'll show you another way to do this as well. But that's 20. What about between 5 and 20? What would the geometric mean be? Yeah, it's 5 times 20. And then you might hit a point at which you can kind of fill in the blanks. You go 5 times what is 10, 10 times what is 20, 20 times what is... So this one's going to be 40. But it'll also work to do 20 times 80, which is 1600, and take the square root to get that. So that works great if there's an odd number in between. You just take the two values you're trying to find the geometric mean between. What was that? 40 times 10, which is the middle one there. I did that. How about 80? 20 times 80 is the last. 20 times 80. That's 1600. 1600 square root of that is 40. 3 means between 64 and 4. This is going the other direction. 2, 3, 4. So you could go 64 times 4, take the square root of that, and it'll give you the middle term. So what's the middle term in there? 16, yeah. This one's going down. Can you tell what this one is then? 8, yeah. And this one's 32. So sometimes you just fill in the blanks once you get one of them. I'll show you another example where it won't quite work like this. I'll show you another way to do it. I can actually do that now. So another way to do this would be, I've got to multiply 64 times something to get this number, times something to get this number, times something to get this number, and then times something to get this number. So I'm multiplying it several times here. So another way to think about this is I have basically 64 times x to what power here? I'm multiplying x to, it's the same time number each time, so it's 1, 2, 3, 4. So it's x to the 4th to equal 4. Well, go ahead and solve that algebraically. Divide each side by 64. X to the 4th equals 4 over 64, or 1 over 16. So this is going to give me my r here. What do I do to solve for x to the 4th? Solve for x when I have an x to the 4th. 4th root, right? So 4th root of 1/16 is 1/2, which is my common ratio. So that's another way to do it, which will work when you only have maybe 2 geometric means between here. I'll show you what I mean. So, like I said, sometimes you can just look at it and tell. You're just filling in the blanks. All right, find a sub 10 of the following geometric sequence. So first of all, we got to write down our formula here. We have a sub n equals, it's a sub 1 r to the n minus 1, and then fill in a sub 10 equals a sub 1 is 5, r we'll get to here, 10 minus 1. So to find r, it's the same way you would find it as you're checking. We just need to check one set of pairs, though, because they have already told us it's geometric. So if I take 5/3 and divide it by 5 over 1, it's the same as 5/3 times 1/5, or 1/3 is my common ratio. And then using your calculator, you can plug that in. Be 5 times 1/3 to the 9th. So 5 times 1 divided by 3, just using parentheses here, to the 9th power. This decimal value, that e-4 means times 10 to the -4. It's in scientific notation, so that would mean moving the decimal 1, 2, 3, 4 places over. If you hit math, oh, still not going to do it. Okay, so let's see how I wrote it down here. it's 5 over 19,683, it looks like. Write that on there. I did it this way, so it kept the 5 up at the top, and then 3 to the 9th. And then 3 to the 9th is 19,683, yeah. So 5 over 19,683, then you have it in fraction form. So that's finding the 10th term. And then this is kind of like what we did with the arithmetic sequences. Here we're given a term that's a little farther into it, like the 3rd term into it. And we're asked to find the 8th term. So if we go after the 8th term, it's a to the 8th equals a to the 1st, which we don't know, and then r to the 8 minus 1 power, and we don't know r, nor do we know a sub 1. There's multiple ways, I guess, we could go about finding a sub 1. If I could find the geometric mean between these two, right, then I would have 3 terms in sequence, and I could then find r that way. That would be one way to do this. We could also do the equivalent that we did before and start it, like shift it up. Just do a sub 5 in here, a sub 3 here, r to the, and then this would be different. But just because there's only one term in between these two, if I take and find a sub 4 by just taking the square root of 36 times 324, what do you get for a sub 4? Yeah, I get it handy. It's one way to find the middle term there, and then we'll know what r is. What is it? 108. Okay, so I think you can see it now. From 36 to 108, you'd have to multiply by 3, and then from 108 to 324 by 3. So now it's pretty clear what r is. So I've got a sub 8 equals all this. So r is now 3. This is to the 8 minus 1 power. And then a sub 1 you can find by just working backwards, dividing by 3. Would be one way to do it. So a sub 2 would equal a third of that, which is 12, and then a sub 1 is a third of that, which is 4. So then I can put the 4 in. So, you know, algebraically or by using a pattern, somehow you need to find your a sub 1 and your common ratio. And then that ends up equaling, it's like 8,748. And then I want to look at maybe one with fractions in it here. This is the same type of idea. This is the one where, let me go ahead and write the sequence up here. Here's 3/4, that's my a sub 4. And then a sub 5 I don't know, a sub 6 I don't know. And then a sub 7 is 3 over 32. So I end up with just 2 values in between. It's not an odd number, right? So I can't just take 3/4 and 3/32 and multiply them and take the square root. What's going on here is I'm multiplying 3/4 by something, call it x. Then I'm going to multiply that by something else, call it x again. And then that by something else, call it x again. So I really have 3/4 times x to the 3rd power equals the 3/32. Okay, to continue that geometric pattern there. So also some of you are probably looking at this, and I can tell what the pattern is. Some of you can probably see it already. Tell what the ratio is, and so that's a viable method too, especially when something like stays the same here. I mean, it's going to be an 8. Let's see, 8, and then a 16, and then 32. So you kind of can see it. But if you need an algebraic method, this will work. You guys see how I got the x to the 3rd? I'm multiplying by the same thing 1, 2, 3 times is where the x to the 3rd comes from. Okay. So flip and multiply of x to the 3rd equals 3/32 times 4/3. That's equal to 1/8. Cube root of 1/8 would be 1/2. And then we go, oh, the ratio is 1/2. Okay. So 1/2. So this is 3/8. This is 3/16. Why don't I just work backwards now here? If I can do it. There's a sub 3. a sub 2, a sub 1. So going back the other way, what's a sub 3 going to be? 3 halves. Okay. Keep going. What's a sub 2 going to be? 3. And then a sub 1 is 6. So now we have everything we need to find, well, we found a sub 1 already. That's all we needed. So a sub 1 equals 6. That's one way to do it. Probably other ways you could think of to do it. All right, and that last one on there, find a sub 10 in the sequence. This one is, the only difference here is that you have an r that's a negative. See how it switches signs here? So the r is -3 in this case. So a sub 10 equals 4 times -3 to the 10 minus 1 power. Because it's an odd power, it will be a negative number. This one you could probably just keep multiplying on the calculator recursively until you find the 10th one and do it just as quickly as the formula. So you end up with, on this one, -78,732. Just on your calculator, just be careful use of parentheses as you plug these in. That's all. Be aware of that. So that's just a quick little review of finding the nth term of a geometric sequence. All right. So move on to series here. We got some series. We're going to ultimately end up with finding the sum of these ones that are convergent. We're going to talk a little bit about convergent versus divergent. But a series is a sum of a certain number of terms. And when it's a geometric series, then the terms are generated by a common multiplier. So sum of a certain number of terms, plus or minus. An infinite series is a series that continues forever. What's cool about geometric infinite series is that in some cases they have a sum. They converge upon a sum, which is a calculus sort of idea. They have a finite sum, even though it's an infinite series. It's kind of a neat idea. And then others, of course, diverge. I think it's pretty intuitive which ones will diverge up when you look at their sum. So to translate this into like language that we could talk about in Algebra 1, absolute value of r less than 1, what that means is this r is less than 1, greater than -1. You remember that compound inequality? Or even thinking about it this way, maybe r is less than 1 and r is greater than -1. Remember you flip and change the sign? Remember that with absolute value? So that's what that's saying. So in words, r has to be between -1 and 1. So it's like it's a fraction between -1 and 1. And if that's the case, then when you add up the terms generated by that r, they actually have a finite sum. Okay. All right, so I'll show you what I mean. And then divergent, this would mean r is greater than or equal to 1, or r is less than or equal to -1. So if you think about it on the number line, here's 1, closed circle. Here's -1, closed circle right there. Here's 0, of course, in between. And so we're going that way or that way. And so if r is not a fraction between -1 and 1, then the series doesn't have a sum. It just keeps getting bigger and bigger and bigger. That's what we mean by divergent. Does that make sense? Connection here. Picture here would look like this. -1, open circle. There's 1, open circle. So a little connection there to why you learn what you do back in that Algebra 1. It's like third chapter of Algebra 1, looking at absolute value inequalities. All right. So a couple more formulas. Here's the summation notation here. There's the one we just talked about. Generates the nth term, a sub n equals a sub 1, r to the n minus 1. when we want to sum up the terms, we use the sigma or summation notation. And the geometric series formula, this will give us the sum of the first n terms of a finite series is right here. It's a sub 1 times 1 minus r to the n over 1 minus r. So you need to know r, the number of terms, and the first term. And then when the geometric series converges, you can use this infinite geometric series formula to find the sum of all the terms. It's a sub 1 over 1 minus r. So there's a sum. It's an alternating series. You could add them up. You could just type them all into your calculator. That would be without the formula. Okay, so maybe some of you could try that right now and check us here. Here's what the formula would look like for this. This would be S sub, there's 1, 2, 3, 4, 5, 6. So S sub this first 6 terms with a sub 1 equal to negative 15. R here, it's an alternating series. It's multiplying by negative 2. So R would be negative 2 to the 6th over 1 minus negative 2. And you can type it into your calculator like that. Sometimes what I'll do is simplify the bottom before I type it into the calculator. So I can just type in 3 instead of 1 minus negative 2, but whatever. So you type that in. Lots of parentheses here. I already forgot what I was typing in. Negative 15, 1 minus negative 2 to the 6. Okay. So negative 15. Is it to 6 actually? And if you're typing in, I think I had a negative in here, so I need to put parentheses around it. So I already botched that up. So negative 2. No, oh shoot, now it's off. That's the bummer. Negative 2 to the 6th, and then I need to end my parentheses. Okay, so it's negative 15, 1 minus negative 2 to the 6th. If I got all the right parentheses in there, we'll know in just a minute here. Divided by 1 minus negative 2 is just 3. You get 315. So hopefully that's what you got when you added them up. There's just those 6 terms. 315. Really careful use of parentheses here. You got to really be careful with that. I think looking at it, you can kind of tell. Maybe if you mess that up. All right. So see if you can find the following sums here, just using that formula. See if you can just set it up. We can set up together, and then use your calculator. Here, so we have S sub 5 equals a sub 1 back formula here. It's a sub 1, 1 minus r to the n over r, 1 minus r. So we need to know the first term, which we know, 1 minus negative 3 to the 5th over 1 minus negative 3. So go ahead and see if you can plug that into your calculator and get a value. Make sure you can do that correctly with that negative in there. And then I think it'd be worthwhile to try it once with the fractions in there as well. I can give you the solutions. Make sure you could just do that on your calculator. You're just using lots of parentheses to get it in there correctly. Like the 1/3, you got to have that in parentheses in there. So this first one, you should end up with a 732. If you write it in fraction form on the second one, 6 equals, like this, 2/3, 1 minus 1/3, 6th. Minus 1/3. 732 for the first one. Let me know if you get something for the second one. I'm looking at mine. I'm not sure that I forgot a term in here. See, 1 minus 1/3 would be 2/3. 2/3. This should just be 2/3 will cancel. That's convenient. You have 1 minus 1/3 to the 6th. You get 728 over 728. 728 over 728. All right. And then in sigma notation, here it is in sigma notation, you can still use that formula. S sub n equals, it's still a sub 1. We just got to find a sub 1. A sub 1 is 2 times 3 to the 1 minus 1 power. Remember that anything to the 0 power is 1. So this is 3 to the 0 or 1. So that gives me my first term is 2. And then I've got 1 minus r. The r is that multiplier right there. It's the base that you're taking to a power. So 1 minus 3 to the 6th power. Finding s sub 6 here. Whoops, it goes. And then over 1 minus 3. So that's what the plug-in looks like. This should be s sub 6 here. There we go. So that's just translating it from summation or sigma notation into our S sub n series formula for a geometric series. Type all that in, you should get you guys get it already? I'm going to type it in. Did you get it? 728. It's the sum of all those terms. And then once again, we're looking at, in sigma notation, can you quickly identify which ones are arithmetic, which ones are geometric? If any fall into the category of neither? I don't think any of these do. So the first one here is arithmetic, right? And this one would be geometric. The multiplier is the 4, so r equals 4. This one is geometric as well. Geometric as well. This one's geometric right here. We have a multiplier of 5. Geometric here. And then this one's arithmetic. So the geometric ones have a base to a power. That's how you can identify it. And that base is your r. All right. Finally, it's kind of all building up to this final idea here is first identifying which ones of these are convergent, because they have to be convergent to have a sum, okay? And the formula for an infinite series is easier. It's nice. But let's look at these and see which ones diverge first, okay? So to be divergent, that means r is not between -1 and 1. So if you have an r that's an absolute value bigger than 1, then it diverges. So can you tell what the r is in that first series? Yeah, r is 10, so this one, right off the bat, we can just say it diverges. You don't have to find the sum. You can't. What's the r in this one? -1/2, okay. So that one's going to converge, so we can go ahead and find it. We'll come back to that and go ahead and find the sum in just a minute. Let's find the others that diverge. For the other, I think there's one other that diverges. What's the other one that diverges? Yeah, this one diverges. Okay. So now, just write converges. This one converges. This one is r equals 1/2. And this one converges. And r equals -7/8. And this one converges. R equals 2/3. So the formula for convergent geometric series is that, I'll write it down up here maybe, a sub n, or a sub infinity, equals, it's a sub 1 over 1 minus r. So all we need is the first term in the r. Pop them in and you can find what it converges to. So here we'd have 32 over 1 minus -1/2. So that's 32 over 1 plus 1/2, or 32 over 3/2. I think I could do that one by hand. 32 times 2/3. Well, almost. So 64/3 if we leave it there. 64/3. Now, what is that as a decimal? Let's get a decimal for that. 21.3. Repeating it. 21 1/3. Okay. So 64/3. This one would be just the first term, 1/2 over 1 minus 1/2. That one's kind of fun. What does that converge to? 1. Yeah, equals 1. And then here we've got the first term. Well, we've got to find the first term first. First term we're going to get by plugging in 1 right up here. And if I plug in 1 up here, 1 minus 1 is 0. -7/8 to the 0 would be 1. So the first term is 1 over 1 minus -7/8. So 1 over 1 7/8. Simplify that. We get, looks like 8/15. It's 8/15. And then the last one on here. What's the first term of that last one here? If I plug in a 1 right here. What is it?
32 over 20.
Okay, so we get 4. Let me just show you guys where it's coming from. Thirds to the 1 plus 2. So that's where it's coming from for our first term. Say it one more time. You get 30.
32
Okay. So there it is. That's the first term. It's just plugging in 1 to that expression gives you the first term. Once you have the first term and you have r, you're set for finding the sum of the infinite series. So we got 32 over 27 all over 1 minus 2/3. And fun with fractions, just simplify, end up with 32/9 as your sum. So as long as r in absolute values is less than 1, then it will converge and you should be able to find its sum. Any questions on that?